All right, let's get started. Algebraic properties of equality. You should have these notes printed out, okay? Let A, B, and C be real numbers. Our addition property of equality, just like what it seems. This is when we are adding, just like that. So if A equals B, then A plus C equals B plus C. Subtraction property of equality. I'm sure you could figure this one out. When we are subtracting. Okay, so this one, if A equals B, then yes, you guessed it, A minus C equals B minus C. Multiplication property of equality. Same thing. This is when we are multiplying. When we are multiplying. Cool. So this one is if A equals B, then A times B is equal to, A times C is equal to A B times C. Struggle with that one a little bit, ladies and gentlemen, I apologize. Okay. If A equals B, then A times C is equal to B times C, because we know these two are equal to each other. So A is the same thing as B, so A times C is equal to B times C. Division property of equality. If A equals B, then A divided by C equals B divided by C, as long as C does not equal 0. Okay. Both of these are as long as C does not equal 0. What do we think our division property of equality is? How do we think we can put this into our understandable terms? Yep, you're right. It's when we are dividing. Okay, cool. Substitution property of equality. This is when we substitute. When we substitute. We're struggling with how to spell there. Or plug in. So this one is if A equals B, then A can be substituted for B, or B for A in any equation. So this is when you plug it in, okay? I've talked to you guys a lot about that. Distributive property. This guy is when we multiply / distribute to every term in parentheses. Parentheses, okay? When we distribute to every term in our parentheses. So for our sum, A times B plus C would become, distribute my A times B plus A times C. And for my difference, which means subtracting, A times B minus C, distribute to every term, A times B minus A times C. That is our distributive property. Okay, let's do a practice. We're going to solve for x just like we would in Algebra 1, but we're going to justify each one of our steps. Okay, so we're going to first have equations and our reason. So here's our equation. Our equation is just each step, and a reason, that's just my justification. Okay, so my equation is 3x plus 2 equals 23 minus 4x. My reason just that it was given to me, okay? Given. My next step when I'm doing this, I don't like negative variables, so I add 4x to both sides. These are going to cancel out. I get 7x plus 2 equals 23. This reason right here, that's called the addition. Okay, let's look back up here. It's called our addition property of equality. It's called our addition. And instead of writing out property of equality, I'm just going to write POE. My next step, I'm sure you know what it is. Subtract 2 from both sides. These are going to cancel out, so I get 7x equals 21. What was that reason? Subtracting 2 here? You're right. It was called the subtraction property of equality. Subtraction property of equality. My last step, as you all know, is to divide by 7 on both sides. So I get x equals 3. What was my reason for dividing by 7? Correct my division property of equality. And then I have my answer. Awesome work. So I encourage you to go ahead and try this one on your own and justify each step, and then watch the video with me. So hopefully you all tried it on your own and you are ready to check your work. Equation and reason. I have -5 times 7w plus 8 equals 30. My reason was it was just given to me. I need to distribute my -5 to every single term. So I'm going to get a -35w. -5 times 8 is a -40 equals 30. My reason was distributive property of equality. Distributive. Okay. Now my next step is going to be to add 40 to both sides. You could have added 35w to both sides. It doesn't matter. Either way works. So -35w equals 70. That reason was addition property of equality. Okay, if you added -35w to both sides, that's still going to be addition property of equality, and you are going to just have to do one more step by subtracting 30 from both sides, and then that reason would be subtractive property of equality. And then we would all be caught up. So we divide by -35 on both sides, divide by -35, I get w equals -2. That reason right there was called the division property of equality. Okay, and those are our examples. So now let's go into reflexive, symmetric, and transitive properties of equality. Go ahead and flip your page. Reflexive, symmetric, and transitive properties of equality. We will have real numbers. We also have segment lengths. And we also have angle measure. Okay. Draw our lines out. Mine was not straight, I apologize. Okay, read my reflexive property. Reflexive. If you think about that song from Mulan, reflection. What is a reflection? That's when I'm looking into a mirror and I see myself. Looking into mirror and see self. So if A is looking into a mirror, it's going to see itself, so it sees A. Assume that A is a number. If AB looks into a mirror, it sees itself as AB. If my measure of angle A is equal to measure of angle A. That's not a reflexive property, it reflects right back on itself. Symmetric property. If A equals B, then B equals A. Okay. The way I think about this is it just flips, okay? It's symmetrical, so it flips. Symmetric property, it just flips. So for a second segment, if AB equals CD, then CD equals AB, right? It just flipped. Angle measure, if measure of angle A equals measure of angle B, then measure of angle B equals measure of angle A. All right, our next one is our transitive property. This guy is cutting out the middleman. So cut out middle man. Cut out that middleman. So if A equals B and B equals C, then A equals C. Whoa, why does that make sense? If A equals B and B equals C, then why does A equal C? This is because A equals B. Well, I know that B equals B because B is just itself. B equals B. But I also know that B equals C. Okay. Cut out that middleman. Oops, sorry. That B equals C. Cut out that middleman. Okay. Cut out middle man, then A equals C. Okay, that's how our transitive property works. So the segment length, if AB equals CD and CD equals EF, then you guessed it, AB equals EF. Again, why? Well, because AB equals CD, CD equals itself. We also know CD equals EF. Cut this middleman out. Cut out middleman. And I get that AB equals EF. Okay. Angle measurements. If measure of angle A equals measure of angle B, measure of angle B equals measure of angle C. By the transitive property, then we know measure of angle A is equal to measure of angle C. This is because measure of angle A equals measure of angle B, which also equals itself, B. Okay. Which equals, we know from right here, measure of angle C. Cut our middleman out. Cut middle man out. So I get measure of angle A equals measure of angle C. And that's our reflexive, symmetric, and transitive property. So let's name the property of equality that the statement illustrates. If measure of angle 6 is equal to measure of angle 7, then measure of angle 7 is equal to measure of angle 6. What property is this guy? And if 34 degrees equals 34 degrees, what property is this one? And if measure of angle 1 is equal to measure of angle 2, and measure of angle 2 is equal to measure of angle 5, so measure of angle 1 equals measure of angle 5, what property is that one? I'm going to give you some time to answer those questions. So we know that if measure of angle 6 is equal to measure of angle 7, the measure of angle 7 is equal to measure of angle 6. We have a symmetric line right here. We flip it over. You know this is proper symmetric property. What about this one? 34 equals 34. That's going to be our reflexive, right? Because it just looks right back at each other. Property. And our last one, we know that measure of angle 1 equals measure of angle 2. That was this guy right here. But measure of angle 2 equals measure of angle 2, which we know from here tells us it equals measure of angle 5. Okay? So I just added my equations together.